Howdy Tinker Nerds. Recently we've been learning about ultrasonic waves and how to harness their power. So far we've learned how they work, how to make a simple sonar device, and how to control objects using ultrasonic waves. Now it's time for the ultimate test. Let's see if we can make an ultrasonic motion controlled desk lamp. There's a lot to do, so let's get tinkering. You can find the project page for this video at the link below. Here's what you're going to need for this project. An Arduino, 3 ultrasonic sensors, a breadboard and some wire, 2 servos, an articulating desktop lamp, a 5-volt battery pack, a Dremel, a project box, and a switch. Alright, let's start connecting the hardware first. We're going to be using 3 ultrasonic sensors. They'll be used to detect swipe left, swipe right, and forward and back movement. Depending on what type of ultrasonic sensor you have, you may have a different amount of pins. Mine has 5, but we'll only be using 4. You want to connect a ground port on the Arduino to the negative row on the breadboard, and the 5-volt port to the positive row on the breadboard. Now you can connect the ground pins to the sensors of the ground row, and the VCC pins to the positive row. On the left sensor, connect the trig pin to port 8 and the echo pin to port 9. For the center sensor, trig goes to 10 and echo goes to 11, and for the right sensor, trig goes to 12 and echo goes to 13. Using a separate breadboard, let's connect the servos. Start by connecting both ground wires together and both power wires together. Then connect a separate power supply to the motors. But you have to make sure that you also connect the ground to a ground port on the Arduino for this to work. Now connect one servo to port 6 on the Arduino and the other one to port 7. Then connect the Arduino to your laptop and let's start writing some code. To get started, you need to import 2 libraries into your code, the servo library and the new ping library. You'll need to download the new ping library and move it to the libraries folder. Next, let's create all the variables starting with the slide detection variable, true-false variables for the directions, the pins for all the sensors, both of the servos, the pins for those servos, the maximum detection distance, reset and delay variables, and slide direction detector variables. Whew. Okay. After all that, let's write our setup function that sets up the serial monitor and attaches the servos and sets their angles. Now let's write our looping function that starts out by sending a ping signal from each sensor. We'll write this ping function later. Let's also get the distance for our center sensor, another function that we'll have to write later. Next, if the pings from each sensor detect an object, store a last touch variable from that point. Then if the ping time minus the last touch variable is greater than the reset variable, reset the slide and timer. Now if a slide is detected and another slide isn't currently in process, then see if it's detected from the left sensor and start the slide process. Then see if it's detected from the center and right sensors as well, and if so, pass the R string to the slide now function, which we'll write later. Using a similar if statement, you can write the code for the right slide and center distance functionality. Then delay it for 50 milliseconds. After that, let's write the ping boolean function, which is past the trig and echo pins from the sensors. First, we'll get the distance for the detected object, and then we'll check to see if it's within our maximum distance. If so, we'll return a true or false boolean. Now for the getDistance function that also accepts the trig and echo pins as input, and with them we'll declare some measurement variables, set the pin mode, initiate the ping function, and then collect the duration and convert it to centimeters, returning that number. Next, let's make a function that tells what to do when a direction is detected, sending a rotation command whether left or right and printing the results to the serial monitor, and then setting a delay after the slide has been detected. For up and down detection, let's make a function that checks the distance of the object from the center sensor and, depending on how far it is, assigns a U or a D for up or down, and again sets a delay after the slide has been detected. Now for the rotation function. Depending on whether it's an R or an L that's passed to this function, rotate the servo respectively. Similarly, for the vertical function, rotate the servo whether it's a U or D that is passed. You can tweak these values until you get the movement that you desire. Then upload it to your Arduino and test out the functionality to see if it works. The next step is to create a nice little enclosure for all of the electronics. So take in the project enclosure, measure and cut the top with a Dremel so that the servo fits neatly in the center of it. Similarly, on one of the long sides, measure and cut holes for each of the ultrasonic sensors so that they can peek through the front of it like this. Lastly, you want to drill a hole in the opposite side for the power switch. To make sure everything fits, I'm going to use a smaller Arduino and solder everything to a circuit board. I'll also add leads to install a switch and a 5-volt battery pack. You want to use a similar power source to this one to ensure that both servos as well as the Arduino receive ample power. To tweak the Arduino code in the future, you can solder these extra wires to the Arduino to make it easier to connect to. Now to attach the lamp. Making sure you've measured it to the center, attach the base to the bottom servo. Notice how I've already run the wires of the second servo through the base so that I don't have to worry about it later. Now mount the second servo halfway up the bottom armature of the lamp, and then using a strong wire such as a coat hanger wire, attach it to the midpoint of the upper armature like this. For the last step, connect the servos to the circuit board and then attach everything to the inside of the enclosure and screw the base on. Now flip the switch and test out the movement. Mine was very wobbly, so I ended up adding some thumbtacks to help stabilize it. Not perfect, but it works. Now go out and make your own. And if you have any questions, again, you can find the project page at the link below. If you got any value out of this video and would like to give some value back, please consider sending some Bitcoins my way, or consider donating to my Patreon campaign at patreon.com/Tinkernut. Alright, that's it for this episode of Tinkernut Labs. For more, go to tinkernut.com, where technology and creativity collide.